Alright, welcome again in another tutorial of the topic differentiation. So in this tutorial we continue with the applications of differentiation, and today we are going to see this issue of maximum and minimum values. So differentiation can be applied to find the maximum and minimum values of a function. So we have a function here y equals to fx, na hii ndo graph yake. You can see kwamba imeongezeka hapa, ilipofika kwenye a ikaanza kupungua, ikafika kwenye b ikaanza tena kuongezeka, ikafika kwenye c ikaanza kupungua. So hizi points a, b na c tunaziita turning points. These are turning points. Lakini hizi points pia tunaziita jina lingine ni maximum and minimum values. Maximum or niseme minimum values, ambapo kwa kesi yetu hapa a na c ni maximum, a na c ni maxima. Okay, ikiwa moja inakuwa maximum, ikiwa nyingi zinakuwa maxima, singular and plural, wakati b ni minimum. So a na c ni maximum na b ni minimum. Sasa hizi ukisema maximum value, it doesn't mean though it's the absolute greatest value in the whole function. Hapana. For example, a hii ni maximum value, lakini kuna point c ambayo ni kubwa kuliko a. Okay? Au b ni minimum value, lakini unaona huku kuna points kwenye huku kushoto kwa a kuna point ambazo ni ndogo kuliko b. Kwa hiyo hizi maximum and minimum value, they are not the absolute greatest or least value in a function. No, they are not. They are just the maximum value in the neighborhood. Kwa mfano kama a is maximum value in this neighborhood here, okay, and b is minimum value in this neighborhood here, and c is the maximum value in this neighborhood here. So they are not the absolute greatest or least value in a function. They can be though, okay? Because for example, c is a maximum value, but it is also the absolute greatest value in a function. Now consider this scenario here. Let's have two graphs. Okay? So in the first graph, this one is our first graph. You can see that as x, the value of x increases and the value of y also increases. And then we have a second graph here. And then we have a second graph here. So in this graph now, as the value of x increases, the value of y decreases, okay? Kama hivyo. So ipo namna hii. Value ya x increase na value ya y increase, mara nyingi the derivative ya hiyo function ni positive, okay? Ni positive. Lakini kwa kesi hii ambapo x ina increase, y ina decrease, derivative ya huyu jamaa ni negative. Okay, I can prove this now concept. We know that the derivative is equal to the gradient of a curve at a point. We studied this huko nyuma. So the derivative is a gradient of curve at a point. So I'll consider a point P here, okay? It's called point P. and another point P here. So I mean, if I draw a tangent at the point P, okay, so this one is the point P. If I draw a tangent here at the point P, this tangent will form an acute angle with the x-axis. So the gradient of curve at point P will just be the tangent of this acute angle. So the tangent of an acute angle is what? Is positive. Ndio maana na yenye ni positive. Lakini kwa case kama hii ambapo x ina increase, y ina decrease, you can see that the tangent here at the point P forms an obtuse angle to the x-axis. So I mean the gradient, I mean dy dx, which is just equal to the gradient of the curve at P. Is going to be equal to the tan now of this angle. But since this angle is obtuse, then our dy dx is just going to be equal to negative. Okay? Kwa sababu tan ya obtuse angle ni negative. Jaribu mwenyewe kwa calculator yako. Fanya tan labda ya 130, itakuja jibu negative. Lakini tan ya acute angle ni positive. Kwa fanya tan labda ya 30, utaona jibu linakuja positive. Kwa hiyo sasa, when the derivative is positive, it means that y increases as x increases. But when the derivative is negative, it means that y decreases as x increases. So now, for a graph now like this one, okay? So this point is called the turning point, okay? The turning point. Sasa, for the turning point now, there's something different. The tangent so this one is the x-axis and this one is the y-axis. So for the turning point now, the tangent is, I mean the situation is different. The tangent at this point is parallel to the x-axis. So I mean the angle it forms to the axis is 0. So now our dy dx now at the turning point is just going to be equal to 0. So at the turning point, dy dx is 0. So when dy dx is 0, it means we have now either the maximum value or the minimum value. This is what happens. So now if I draw that graph I drew nilivyokuwa naanza hii tutorial, ile graph yetu ya kwanza kabisa kuichora ilikuwa hivi. So we had our y-axis and then also we had our x-axis. So this was our y-axis and this one was our x-axis. So our graph was like this, just went like this, like this, like this, like this. Okay, we had our A, our B and our C. So the derivative here is positive, okay? Kwa sababu x increase na y ina increase. Lakini ikifika kwenye turning point the derivative is 0. Alright? Hapa sasa the derivative now is negative kwa sababu unaona kwamba x inavyo increase y ina decrease. Lakini ikifika kwenye turning point the derivative is 0. Okay? Baada ya B sasa the derivative inakuwa tena positive because as x increases, y increases. Okay? Then ukifika kwenye turning point, the derivative is 0. Baada ya hapo now, the derivative inakuwa negative tena because as x increases, y decreases. So this is the situation. So angalia maximum points, okay? Maximum points. Ambazo ni nani hapo ni A and C. You can see that the derivative changes, dy dx changes from, you see, positive to negative. Positive to negative. Of course, it's from positive to negative. This is how you determine a maximum point, the derivative will change from positive to negative. Lakini kwenye minimum point ambayo ni hiyo hapo, point B, ni hiyo point B, okay? The derivative now, dy dx, it changes now. It changes from negative to what? To positive, like this. So it's from negative to positive. So ukitaka kujua maximum point, unaangalia how the derivative changes from where to where. Na ukitaka kujua minimum point, how the derivative changes from where to where. So let me just do one example that will strengthen our understanding. So I call this example 1. So example 1 says, bear with me as I write the example. Find the turning point on the curve y is equal to x squared minus 2x, and determine whether it is a point, of maximum or minimum y. So this is what we want to see here. So this one is y is equal to x squared minus 2x. So find the turning point. Sasa remember nilisema kwamba at the turning point the tangent at that point is parallel to the x-axis. Kwa tukajua kwamba dy, the derivative is equal to 0. Remember, just rudia tena video, you'll see that. So this one is at the turning point. So at the turning point dy dx is 0. So what is dy dx anyways? So dy dx, kumbuka tumesoma sana hii derivative of polynomial functions. Okay, I'm just going to be very quick. Dy dx, so nikidifferentiate x square I just get 2x. Nikidifferentiate 2x I get 2. This is my dy dx. So the turning point dy dx is 0. This means at turning point, at tp, I mean dy dx now, which is equal to 2x minus 2 is just equal to 0. So 2x minus 2 is equal to 0. So at the turning point, 2x is equal to 2. Hii 2 naileta huku. So at the turning point, x is 1. So at at x is equal to 1 ni turning point. So at x is equal to 1, what is y? Narudi huku sasa. So from hapa, y equals to x squared minus 2x, okay? Y is just going to be 1 squared, kwa sababu x ni 1, minus 2, 1. So y is negative 1. So this point now, 1, negative 1 is our turning point. Okay, so tumeshapata the turning point. So turning point yetu ni our turning point x, y is just 1, negative 1. So now, is this a maximum or minimum value? Okay, so nimesema x ni sasa na 1 at the turning point. Less than 1 ni 0.9, okay? Chukua tu 0.9. Alafu greater than 1 ni 1.1, okay? Sasa, remember, maximum point, the derivative changes from positive to negative. Wakati minimum point, the derivative changes from negative to positive. So in order to determine if this turning point is either maximum or minimum, we need to see whether the derivative changes from positive to negative or from negative to positive. Now remember, dy dx tunapata is equal to 2x minus 2. So when less than 1, okay, for less than 1, okay, dy dx itakuwa ni sana 2, c ndo less than 1 tumechagua. So it's just 1.8 minus 2. Okay, 2 times 0.9 is 1.8 minus 2, which is going to be negative 0.2. So this one is less than, at less than turning point. Now what about at greater than turning point? So dy dx equals to 2x minus 2. So dy dx now is going to be equal to 1.1 into greater than 1, okay? Greater than turning point minus 2. This 2.2 minus 2 is equal to what? 0.2 positive. So at greater than TP. So you can see that at the derivative at the turning point changes from negative to positive. Okay, so it changes from negative to positive. So our turning point ambayo tulipata pale ambayo ni 1, negative 1 is a minimum value. Okay, so that's a short presentation today about the application of differentiation kwenye hiyo concept ya maximum and minimum values. Let me just say, see you in the next tutorial.